On the back of the review, we start out trying to find the other endpoint given one endpoint and the midpoint. We know that the other endpoint is in the format x, y. We know that our midpoint is our x average and our y average. So we know that our midpoint was found by averaging the x values of our two endpoints. So positive 10 and x is our other x value. Average them, so we add them together and divide by 2. And we got x bar, which is negative 11. Negative 11 is a whole number, so I'm going to put it over 1. I can solve this by cross multiplying. 1 times anything is itself. So 10 plus x is equal to 2 times negative 11, which is negative 22. I need to subtract 10 from both sides of my equation, which means that x is negative 32. My y values, I averaged negative 10 with y to get 6. 6 is the whole number, so I put it over 1. I'm going to cross multiply. So 6 times 2 is 12. We've got 1 times negative 10 plus y. I need to add 10 to both sides this time. So my y is positive 22. And that means my other endpoint is negative 32, positive 22. Again, my endpoint is in the format xy. I know that my midpoint is x bar, y bar. I've averaged my x's of my endpoints to get negative 5, which is my x bar. Number, so it's over 1. Cross multiply 2 times negative 5, negative 10. Add 7.3 to both sides. And x is negative 2.7. I averaged my y's to get 3.9. 2 times 3.9 is 7.8. Subtract 0.38 to both sides of my equation to get y equals 7.42. The coordinates of my other endpoint, problem 24, are negative 2.7, 7.42. Okay, I'm next asked to find the distance between each pair of points, and I'm asked to round to the nearest tenth if necessary. We know that vertical and horizontal lines, we only have to count. So 1, 2, 3, 4, 5, 6, 7. 7 units. 1, 2, 3, 4, 5, 6, 6 units. All I had to do on 25 and 26. 27, I'm going to want to use my slope triangle. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 for my rise. And for my run, I can use my Pythagorean theorem. I'm going to find the distance here, which is my c, it's my hypotenuse, it's across from the right angle. I've got 64 plus 4 is equal to c squared. I need to square root both sides, which means c is equal to the square root of 68. It asks me to round to the nearest tenth, so when I punch that in my calculator, I get that c is approximately 8.2 units. Okay, over here, I need to use the distance formula. Now, I know that the distance formula is derived from the Pythagorean theorem. So if I square root both sides, I know that we've got c is equal to the square root of a squared plus b squared. And I know that I just used the sides of my slope triangle, so we're dealing with our rise and our run here. So our actual distance formula is d is equal to the square root of x2 minus x1 squared plus quantity y2 minus y1 squared. I'm just going to plug in. We've got negative 5 minus 1 quantity squared plus 7 minus 8. Negative 6 squared plus 1 squared. Negative 6 squared is 36. 1 squared is 1. So d is equal to the square root of 37. And rounded to the nearest tenth, d is approximately 6.1 units. Okay, now we're asked to find the distance and leave our answer in simplest radical form. So again, on the graph, we're going to count our rise and our run. We've got 3 for our run, 3 for our rise. A squared plus b squared equals c squared. Three squared is 9. 9 plus 9 is 18. We need to square root both sides, so c is the square root of 18, but we now need to simplify square root of 18. Splits out into 2 and 9. 2 is a prime number. 9 is not. 9 splits into 3 and 3, which gives me a pair of 3's under the radical, so I get a 3 outside of the radical. So c simplifies to 3 square root of 2. Okay, over here, again, the distance formula. It's just a modified Pythagorean theorem. And the minus and negative becomes plus, so it's negative 4 plus 2, which gives me negative 2. 4 minus 6 gives me a negative 2 as well. I have to square those. Negative 2 squared is 4. So 4 plus 4 is 8. So we've got the square root of 8. And we need to simplify. So the square root of 8 splits off into 4 and 2. 2 is a prime number. 4 is not. So 2 times 2 times 2. Got a pair of 2's. 2 comes out and 2 stays in. So d is equal to 2 square root of 2. And problem 31, you are given a kite. You are asked to find the area and the perimeter of this kite. So first of all, let's go through the area. Area of the kite is d1 times d2 over 2. Let's find our diagonals. You can just count the diagonals here. I'll have to use the distance formula. So 1, 2, 3, 4, 5, 6, 7. Another diagonal. 1, 2, 3, 4, 5, 6. 7 times 6 is 42. And 42 divided by 2 is 21 units squared, since we're dealing with area. Now we know that we need to find the side lengths in order to find. We know it's a kite, so we know that this length is going to be the same as this length, and these two are going to be the same as well. So we're only going to need to do the distance formula twice. So on this one, I have a 2 side and a 3 side. So this side is the square root of 13. And this side is the square root of 13. So down here, I get a 3 side and a 5 side. 3 squared is 9, 5 squared is 25. That 34 is equal to c squared. Now we know that my perimeter is equal to the sum of my side lengths. So I have 2 sides, so the square root of 13. And I have 2 sides, so the square root of 34. And when I round to the nearest hundredth, I get my perimeter is approximately 18.87 units. Okay, on 32, I have trapezoid ABCD. Okay, my area for a trapezoid is 1/2 B1 plus B2 times the height. My bases, I can just count my bases. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. It actually needs that table. One more than it's supposed to do. Let's go back and fix that. My bases are still 4 and 7. My height is 4. Okay, when I punch that in my calculator, I get that my area is 2 times 11, which is 22 units squared. Okay, for my perimeter, I know 2 of my sides currently. I need to find the other 2 sides. I'm going to need to do the distance formula twice. This one I have a 2 side and a 4 side. Down here I have a 1 side and a 4 side. 4 plus 16 is 20. C is equal to the square root of 20 on that side. So 1 plus 16 is 17. So the other side is the square root of 17. We don't have to try and simplify our radicals yet. We're just rounding our final answer here. We know that our perimeter is the sum of our sides. We have a 4 side. We have a radical 20 side. This is the sum, so we're adding here. We have a 7 side. We have a radical 17 sides. When we punch that in our calculator, our perimeter is approximately 19.56 units. Okay, the last two problems. So we're proving quadrilaterals here. We need to come down and look at our quadrilateral. For problem number 33, look at the questions that we're asked to find. So we're asked to find the slopes of the sides, first of all. So we know that slope is rise over run. So I'm not rising any at all. I'm running 1, 2, 3, 4, 5. That simplifies to 0. Over here, I'm rising down 1, 2, 3, 4. That's negative 4. And I'm running 1, 2, 3. It's a positive 3. I can't simplify that anymore. Down here, I'm not rising at all, so that's 0. And I'm running 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 divided by anything is just 0. And over here, I'm rising 1, 2, 3, 4. And I'm running 1. Can't simplify that anymore. I'm going to go ahead and mark these up here. Just 0. Negative 4 over 3. 0 over 9. And 4 over 1. We want to mark any parallel sides. Do we see any with the same slopes? Same slopes. Yes. A, B, and C, D have the same slope. So let's mark those. Do we have any perpendicular slopes, opposite reciprocals? No, we don't have any opposite reciprocals. Okay, how many pairs of parallel sides do we have? We have one pair of parallel sides, which means we do need to test the non-parallel sides to see if they're the same length. So we got to use our distance formula here. So we can use our slopes triangle. So I got a 4 side and a 1 side. 4 squared is 16, 1 squared is 1. So 16 plus 1 is 17. So C is equal to the square root of 17 over here. And then my other one, I've got negative 4 for my slope and positive 3 for the other portion of my slope. My rise was negative 4, my run was positive 3. Negative 4 squared is positive 16, 3 squared is 9. Okay, so 16 plus 9 is 25, which means that C is equal to 5. We see that those are not congruent. They are not the same. So we know that if we have one pair of parallel sides and the other sides are not the same, we know that we're dealing with just a plain trapezoid here. We can go ahead and name that. Let's finish answering the questions though. With the slope of AC, I have to go down 1, 2, 3, 4. And write 1, 2, 3, 4, 5, 6, 7, 8. So negative 4 over positive 8 simplifies to negative 1 over 2. And then the slope of BD, I'm rising 1, 2, 3, 4. I'm running 1, 2, 3, 4, 5, 6. Which reduces to 2/3. My diagonals are not perpendicular. We already know that we're dealing with a plane trapezoid here. Okay, the last problem. I want to find our slopes. I'm going to draw my slope triangles here. I've got 3, 4. Okay, my rise is negative 3. I'm going down 3. My run is positive 4. My rise is positive 3. My run is positive 4. My rise is negative 3. My run is positive 4. Okay, so we have 3/4, so negative 3/4, 3/4, and negative 3/4. Do we have any parallel sides? Yes, we have two pairs of parallel sides here. We do not have any perpendicular slopes. We have negative slopes, but they're not negative reciprocals or opposite reciprocals. So we don't have any perpendicular sides, just parallel sides. We have two pairs of parallel sides, no perpendicular sides. Okay, let's find the slopes of AC and BD. I have no rise. I have a run of 8. Simplifies to 0. I have a rise of 6 and a run of 0, which simplifies to undefined. And we know that 0 and undefined are opposite reciprocals of one another. So yes, my diagonals are perpendicular to one another. I do need to mark that. So I have two pairs of parallel sides, no perpendicular sides, but I do have perpendicular angles, which means I have a rhombus.